Today we'll discuss some more scheduling algorithms. As I have already told, from module 2, definitely the questions are going to long questions are from these problems, from these scheduling problems. All questions will be from these problems only. One of the scheduling that we have discussed is the fast come fast serve. This is the simplest scheduling, fast come fast serve. The job that arrives first will be solved first. This is the simplest algorithm. And we could able to compute the waiting time and turnaround time and all this. But what is the drawback we found over there in FCFS? Anybody who can say what is the drawback of FCFS algorithm? Anyone who can say that what is the drawback of FCFS algorithm that we have discussed in the previous class? What is the drawback of FCFS algorithm?
Starvation.
Starvation? No, I don't. Starvation is there, but what is the problem over here? Main problem is that we have discussed about the convey effect. That leads to starvation, obviously, but the effect is known as the convey effect. The utilization, your CPU utilization might be, throughput may be very less, because once a longer process is executing, other shorter processes has to wait. So few number of tasks may be completed, and so throughput will be less. So solution for the same, we can go for another kind of scheduling algorithm. It's called the shortest job first. What we'll do over here, we'll give priority to the jobs which are having the shorter burst time, shorter execution time. So for that, we must know that what is the length of the CPU burst. What is the length of the CPU burst, so that we could able to give the chance to the shorter jobs first, and then to the longer jobs. Correct? So if I give the same example that I have given for a Xerox shop, that now what the Xerox shop will, the shopkeeper will do, it will first see that who are the people who are standing over there in the queue, and it will find that who is having the least number of pages to be xeroxed. So he will give the chance to the person, and accordingly he will go on giving the chance to the persons having the less number of papers to be photocopied. Correct? So this kind of scheduling is called the shortest job next scheduling. Shortest job next scheduling. So here what associated with each process with the length of the next CPU burst. Here what is given? The next of the next CPU burst is given. So use this length to schedule the process with the shortest time. If the next CPU burst of two processes are same, this is important. Suppose two processes has the same CPU burst, 5 seconds and 5 seconds. What it will do? It will do the fast come fast serve among these two who has came first. Correct? If two processes has the same CPU burst, then FCFS is used to break the time. It is not only for SJF, for any kind of scheduling over here, with that we will discuss. In every cases, do remember that if two processes have the same priority, same burst time, if you have conflict somewhere, to break the tie, the FCFS is used. So there are two versions of this SJF scheduling. One is called the preemptive SJF, another is non-preemptive SJF. Non-preemptive means during the execution, somebody is saying that to give the PPT. Yes, I will give the PPT. Yes, I will give it. I will give it by today. Okay, so there are two versions of the SJF scheduling. One is preemptive, another is non-preemptive scheduling. Now, non-preemptive scheduling says that you already know that once the process is assigned to the CPU, CPU will not release unless the process has been completed. There is a preemptive version of the SJF that is called the shortest remaining time next. I will discuss that what is shortest remaining time. But from this slide, You remember 2-3 things. One is that it uses the what shortest time for scheduling. There are two versions, preemptive and non-preemptive version of this SJF. And remember, among all CPU scheduling algorithms, SJF algorithm gives the minimum average waiting time for a given set of processes. For a given set of processes, it gives the minimum average waiting time. It gives the minimum average waiting time. Question will come, which algorithm, which scheduling algorithm, CPU scheduling algorithm gives the minimum average waiting time? Then it is what? Shortest job fast. Then you will say that if this gives the minimum average waiting time, this should be used. Why will go for other? Why will read the other algorithms? But try to understand. Knowing the length of the next CPU burst is quite difficult. How will you know that how much time the process will take, which will going to execute? So looking into the future is quite difficult, right? So although it gives the minimum average time, but implementation is difficult, right? As it gives the minimum average waiting time, so therefore maximum throughput, more tasks can be completed, because in this scheduling technique, shortest jobs are executed first, right? Let us take an example. Look it carefully. We have 4 processes, P1, P2, P3, P4, correct? This is the burst time is given. What is burst time? Burst time is the execution time that is given, correct? How will you execute? We'll give emphasis to the process having the minimum burst time. So among these, which process will be selected? Which process will be selected over here?
P4.
P4. So P4 is given how much? 3 seconds. So 0 to 3. Then what? Then P1. So 3 to 9. 3 to 9. 6 seconds it takes. Assuming second set is in. So in P3, 7. So 9 to 16. And then you can go for 16 to 24. Is it understood or not? What is the waiting time for P1? What is the waiting time for P1?
3.
What is the waiting time for P1?
3.
For P2?
16.
16.
For P3?
9.
And for P4 it is?
0.
24.
Okay, very okay. So is it understood now? Now we'll go for the next. So we found that for P1 it is 3, P2, P4, and we compute the average waiting time. Like that, can you compute the turnaround time or not? Turnaround time is waiting time plus burst time. Waiting time plus burst time. P1 waiting time is 3, burst time is 6, so 6 plus 3, 9. So like that you go on adding and find the average. Can you compute or not? Can you compute the turnaround time or not? Is there any doubt? Okay. So we'll go for one more example. This example what I have given is the simplest one. But now you look over here. Now you look over here. I will start Excel, that will be fine. Okay. Now the process P1, 2, 3, 4 is given. This is the arrival time and the I'll write this process arrival time, burst time. So process P1, P2, P3, P4, we may have a number of processes over here. Some processes are over here. P1, P2, P3, P4, 0, 2, 4, 5. So 0, 2, 4, 5. 0, 2, 4, 5. Correct? P5 not there. And the burst time as given as 7414. So 7414. 7414. This is given, correct? This is the arrival time and burst time. I want to go for drawing the Gantt chart over here, right? So which process will execute first? Can you tell me which process will execute first? Anybody who can say which process will execute first?
P3.
P3.
P1.
P1 will execute first.
P1,
Right?
P1.
Try to understand over here. Although P3 has the minimum minimum burst time, but at the time 0, none of the process has arrived. When the shopkeeper opens the shop, that time nobody was there, only P1 is there, correct? So even if it has 7 burst time, it has to execute because at that time nobody was there, right? So it will take from 0 to 7. This will take from 0 to 7. Is it understood or not?
Yes, sir.
Now after P1, so P1 is executing for how many times? 7 seconds. So in between 7 seconds, P2, P3, P4 has arrived or not? Because it has taken 7. You can see over here, all is less than 7. So in between 7, when the P1 was taking 7 seconds to execute, in the meantime, P2, P3, P4 has arrived. Do you agree or not?
Yes, sir.
Okay. So that means now all this process time we know. So which one will execute now?
P3.
P3.
Now P3 will execute because I have to find out the minimum. So what is the time for P3? 1. So it is from
7 to 8.
7 to 8. 7 to 8. Correct? Now next one is, okay. Now you see, they both are having the same burst time or not? P2, P4 having the same burst time. Which one will be execute now?
P2.
P2.
To break the tie, we will use the FCFS. So among these two, who has came first? P2 has came first. So we'll write P2 over here. And then P4. For P2, it is how much? For P2, it is 4. So 4 means it is from
8 to 12.
8 to 12. From 8 to 12. And how much for P4? P4 it is from 12 to how much? 4, 16. Correct? Is it understood or not? Can somebody say that what is the waiting time for P1? What is the waiting time for P1?
0.
0. Why it is 0? Because it got at 0. It got for execution 0, arrival at 0. So it is waiting time is 0. For P2, what is the waiting time for P2?
8.
6.
See, P2 is waiting for 8. It is correct, but it has
6.
came after 2 minutes. So therefore, it is 8 minus 2. Is it understood what I am saying? Are you getting me why it is 8 minus 2? P2 got at 8, that is true, but it has arrived 2 seconds later also. Therefore, it is waiting actually for 6. Is it understood? Second one for next one for P3. P3 is got at what time? 7. P3 got at 7, but came at what? 4. So 7 minus 4. Is it anybody having doubt? P3 got at 7, arrival at 4. So 7 minus 4, it is actually waiting for 3. P4 got at 12, arrival at 5. So 12 minus 5. This is the waiting time. So we have waiting time of 0, 6, 3, 7. And we can find out the average. And you know that how to find out the average equals to that I can write directly. 0 plus 6 plus 3 plus 7 divided by 4. Is it understood what I am saying? Can you find out the turnaround time now? For turnaround time, what will do? Waiting time plus burst time. So C2 plus F2 equals to C2 plus F2. And this is C3 plus F3, and you compute in that way. This is so 6 plus 4, 1 plus 3, 4 plus 7, and you compute it over here. That equals to 7 plus 10 plus 4 plus 11 by 4. Is that understood, or anyone having doubt? All of you understood or not? Anyone having doubt, you ask me over here. Okay, so I believe all of you understood this one. So now what, see over here, this is P1, P2. So what is the average time? Waiting time over here. This is 4 we have computed. For non-preemptive, we have computed it to be 4. Is the SJF the way we have computed is for non-preemptive. This one what you have computed is for the first one, this one. We have computed for non-preemptive. That means once the P1 is given, it will execute for the entire time. If P2 is given, it is given for entire time. P3 is given, we cannot take it out during the execution. We cannot take out the process during the execution. Is that understood? Now, there is another version of this SJF is called the shortest remaining time first. This one, shortest remaining time first. This one. What is the shortest remaining time first? This is the preemptive version of SJF. What is SJF? Only SJF is non-preemptive. SRTF is the preemptive version of SJF. Preemptive version of SJF. What do you mean by this preemptive version? Everyone try to understand over here. What is this preemptive version? For example, if I take the same example, the shopkeeper, in SJF, what it does, it allows the person who is having the minimum number of pages to be xeroxed. In SRTF, what it does, suppose it was given when it opens the shop, P1 is at the same time, he has 7 pages to xerox. So as no other process was there, so it will start doing for the P1. After 2 seconds, just after 2 seconds, P2 has arrived. After 2 seconds, suppose P2 has arrived. It's after 2 seconds only. So till the time, how much pages has been xeroxed for the P1? What is the remaining time? 2 seconds it has already executed. So what is the remaining time for this one? Is it understood or not? P1, when P1 arrives, at that time no other process was there. So therefore P1 is given the chance. Therefore P1 is given the chance. Correct? So P1 was executing. During its execution, exactly after 2 seconds, P2 arrived. When P2 arrived, what is the time for P2? For P2, the gross time is 4. So till the time 2 seconds has already executed by P1. So remaining time is 5. So the remaining time is compared with the gross time of the current one. Is it understood? The remaining time is compared with the gross time of the current one. Whoever is having the minimum gross time, that process will be given the chance. Is it clear? Suppose first person is going for having a xerox of 7 copies, 2 copies it has xerox, and the meantime another people come having 4 pages. Now it has 5 pages and these people have 4 pages. So it will give chance to the second one. So therefore P2 will start. So P1 will be preempted. P1 will be preempted, although it has not been finished. P1 has not been finished, but it will be preempted. Right? Now who will be given chance? The P2 is given the chance. So P2 will start executing. P2 is executing. In the meantime, after 2 seconds, again P3 arrived. Just after 2 seconds. Just after 2 seconds, who arrived? The P3 arrived. When P3 arrived, so that means for 2 seconds at least, the process P2 has executed or not? Are you getting me? P2 has got at least 2 seconds for execution. So what is the remaining time? Remaining time is 2 seconds. And for the new process, what is the time? Burst time, it is 1. So what is the shortest among 1, 2 and 5? This has not been finished. This is 2 and this is 1. So who is having the shortest burst time now? Shortest burst time is P3. So P2 will be preempted and the P3 will be given the chance. P3 will be given the chance. Right? So P3 is executing, but just after 1 second, exactly after 1 second, again after 1 second, the P4 has arrived. So that means these have executed at least for 1 second. So that means now this has 0. So the nothing, it has 0 now. Right? So P3 has executed all its parts. So this is completed. P3 is completed. Correct? So now this is 0. So P5 is 4. So among 4, 2 and 5, which is the smallest? 4, 2 and 5. P2 is smallest. So P2 is given the chance. P2 is given the chance. Now no other process is there. So P2 will execute for 2 seconds. P2 will finish. P2 will finish. Then what is left? P1 and P4. Among these, which one is the smallest? P4. So P4 is given the next chance. So P4 will finish. And then P1 will be given the chance. And P1 will finish by taking 5 seconds. Is the Gantt chart understood for SRTF? This is SRTF is important actually. SRTF is important. If you have understood, it's okay. Otherwise, I will tell you once again. There's no problem.
Once again.
Okay. Okay, I'm going for the same. I'll go for the Excel. It will be better if I go for the Excel and show you there. So this waiting time and this I'm deleting. I'm also deleting this. My problem is same. My problem is process, the arrival time, burst time is given. Correct? How will you solve with SRTF? Do remember I am doing for SRTF. I am doing it for SRTF. Shortest remaining time next. Always we will compare with the remaining time. Who among these processes looking into arrival time, who will execute first? Anybody who will say who will execute first? Looking into this arrival time.
P1.
P1 will execute. Very good. Suppose two processes having the arrival time 0. Who will execute first? Two processes are given with arrival time 0. Who will execute first?
The one having less burst time.
No. See. If two processes, yes, that is correct. If two processes having 0 arrival time, then among these two processes, we will see that which is having the less burst time. This is correct. Less burst time. Is that clear? So now, as we have, if two processes having the same arrival time and same burst time, then what will use? We will use the FCFS. Then we will use what? FCFS among them. As both are 0, so you can take any one of them. Maybe it is always advisable to choose which one is written first. That we can select. Correct? So anyway, that we are going for this problem. P1 will execute first. All of you agree for P1 will execute first or not? So P1 will execute first. So P1 is started executing. Now during its execution, what happens? That after some time only, where is that? So after some time, that P2 arrives. P2, so that you could understand. So now look over here. P1 is executing. Just after 2 seconds, P2 arrived. So P1 has executed at least for 2 or not, at least for 2 seconds. P1 has executed for 0 to 2. And after that, P2 has arrived. So what is the time left for this one? For P1? P1, so it was 7, it was burst time, but minus 2. Now what is left? 5 is left. Is that clear? When P2 arrives, that time P1 has remaining time of 5, P2 has burst time of 4. Now the remaining time of the previous processes are compared with the execution time or the burst time of the currently incoming process. So this remaining time 5 is compared with the current time 4, which is having this among 2, which is less. P2 is less. So therefore P2 will give the chance to P2. So P1 has not finished, it is still there. So P2 is now executing. P2 is started executing, but you can see this is arrival time 2 and arrival time 4 is P3. That means after 2 seconds P3 has arrived. So P2 has executed at least for 2 seconds. So that means it has executed from 2 to 4 at least. So what is the time left for 2 seconds if it is there? Then what is the time over here? 4 minus 2. 2 seconds is still remaining. Hello? Are you getting me? Are you getting me or not?
Yes, sir.
Yes, sir.
Okay, so now this is P2. Now, when P3 has arrived, so its burst time is 1. What is my rule? Rule is that I will compare the burst time of the current one with the remaining time of all other processes. Remaining time of all other processes are 5, 2 and 1. Which one will execute first? P3 will execute now. So now P3 will execute, but P3 will execute for at least for how many? For 1 second, because just after 1 second P4 has arrived. So it will execute from 4 to 5. This will execute from 4 to 5. So this is 1 minus 1 equals to 0. So this has finished its execution. Correct? Now in the meantime P4 has arrived. P4, so incoming process arrival, the incoming process burst time is 4. That will be compared with the remaining time of other processes. This is finished. So remaining time of other processes are 5 and 2. So 5, 2 and 4. Among these two, which one is smaller? P2 is smaller. So I'll again give the chance to P2. So P2 will execute for how many? 2 seconds. So 5 to 7. 5 to 7. P2 will execute. So P2 has finished. So this is finished and this is finished. These two are finished. So now what is left? Remaining time 4 over here and this is 4 over, so 5 over here and this is 4. Are you getting me or not? So which one will execute now?
P4.
P4. So P4 will execute. P4 will execute for 4 seconds. So I'll give it to P4 from 7 to 11. I'll give it for 7 to 11. Correct? And then we get again P1 will come and that is for remaining time 5. So 11 to 16. 11 to 16. Is it understood?
Yes, sir.
Okay. So we can see over here in our previous case also this was from 0 to 16 and this is P1, P2, P3, P2. So this is we have got over here. Now question is that this is okay. There is no problem. You have computed this. That is fine. Now question is that how to compute the waiting time, because P2 has arrived 2 times, P1 has arrived 2 times. You know, there are different times they have arrived. We'll compute. How will you compute the waiting time? Do remember that, look over here very carefully. This waiting time computation is very much important. Just look over here the way I am computing the waiting time. Look over here. How we are computing the waiting time. So we'll go for computing the waiting time for P1 first, right? Try to understand at what time P1 got at 0. What time it has arrived? It got at 0. What time it has arrived? It has arrived at 0. Is it understood or not? P1 got chance at 0, arrived at 0. So 0 minus 0, that is 0 plus. At what time P1 again got the chance? P1 got chance at again at what time? 11. But what time it has left? P1 has left with 2. Are you getting me? P1 has left at 2. Processor has released P1 at time 2. Again got the chance at 11. So actually 11 minus 2 it is actually waiting. 11 minus 2 it is actually waiting. Do you agree? Do you understand?
Yes, sir.
Yes, sir.
Anybody having doubt? Just look over here. P1 left at 2. Again got a chance at 11. So 11 minus 2 is actually it is waiting. Now we can say for P2, how to compute the time for P2? P2 we can say 2. P2 got at 2 or not?
Yes, sir.
Then 2. Then what I'll do?
-2.
Very good. 2 minus 2, because 2 is the time it got. 2 is the arrival time. So 2 minus 2. Then plus. P2 has again got a chance.
5 minus
5
4.
minus 4.
5 minus 4.
Very good. 5 minus 4. Correct? For P3, P3 got at 4.
minus
4
1.
minus 4.
4 minus 4. 4 minus 4. See, P3 got at 4, arrived at 4. So 4 minus 4. Then for P4, it got at 7 and arrived at 5.
7 minus 5.
Very good. Is that understood? And now we can compute. So this is 9, this is 1, this is 0, this is 2, and you can compute that 12 by 4 is 3. Average waiting time is 3. Then waiting time for this is the waiting time we have computed, and average waiting time will compute. Turnaround time is gross time 7 plus 9. This is 7 plus 9. This is what? Gross 4 plus 1. 4 plus 1. This is what? 1 plus
0.
1 plus 0. 1 plus 0. And here how much? 5 plus 2.
4 plus 2.
4 plus 2.
It's 4. So it is 4 plus 2. And you can find out the average of turnaround time and waiting time. Is that clear? Easily understood to everyone? A problem will definitely come from this SRTF. I am telling you before. Acha, I have computed waiting time and turnaround time till you know that how to compute. If I say, what is the response time? What is the response time? Can anyone say what is the response time? Response time is the fast waiting time is the response time. That means when the process is fast responded. when the process is first responded. P1 is first responded at 0 time, so response time for P1 is 0. P2 is first responded at 2, arrives at 2, so it is 0. So the first one only you will consider. For P3 it is 4 minus 4, it is 0. P4 it is only 2. So see over here. So everybody having a very quick response. They are responded quickly. They are waiting for some time, that is different. But the moment they are being entered, immediately they are being responded. Is that clear? Can you compute the response time or not?
Yes, sir.
Very good. So we'll go for, so this is computed and it computed to be 3 and okay. This example, can you do of your own? For SJF, it is very simple. This is SJF means it is non-preemptive. For non-preemptive, arrival time with 0, the first one will definitely P1 will execute for 8 seconds. Then the next one, smallest is 4. So P2 will get the chance. Then this is 5, so P4, and then it is P3. I don't think there is a problem in non-preemptive. Is there any problem in the non-preemptive? Can you compute the waiting time and average waiting time, average turnaround time and all this?
Yes, sir.
Non-preemptive, there is no problem, or anybody having problem, please feel free to ask over here. Non-preemptive is very easy. You just look into the arrival time. If the arrival time is 0, looking into the, if you find at a particular time, suppose P1 has finished the execution. So for example, P1 is finished at 8. Every other process is coming after 8. Suppose 10. So what you will do over there? After 8, now think it is, now it is being all are not, no process are there. So CPU is sitting idle. So next the processes will arrive, among them again you will choose. And that time, if the processes are arrived at the same time, then you have to select with the minimum burst time. Now problem is again for this what SRTF. In SRTF, what you have same process over here. P1 will definitely execute. There is no problem. P1 will execute, but exactly after 1 second, that means 1 second it has already executed. So what is the remaining time? Remaining time is 7. So remaining time is compared with this one. P2 is having the minimum, so P2 has got the chance. Then after 2 seconds, so this will execute after 1 second. After 1 second, P2 will execute at least for 1. Just look over here. For example, here. After 1 second, P3 has arrived. P3 has, what is the, so 1 second means it has executed for at least for 1 second. What is the remaining time? The remaining time is 3. Now P3 has arrived. What is its burst time? 9. So we'll compare 9, 7 and 3. Which minimum? P2 is minimum. So P2 will again continue. P2 will continue for at least for 1 more second. P2 is continuing for 1 more second. 1 more second. So 3 minus 1. 3 minus 1, 2. The P4 has arrived. So what is the burst time for P4? 5. So 5, 1 and 7. We found that this is the minimum one, and this will continue up to. So all 4 seconds will be consumed by P2 only. Is that clear? And as the in the meantime, every process has arrived. Then among the rest, I will select the P4. Then I will select the P1, and then I will select the P3. Is that understood, or I will explain it again?
Sir, again explain.
Okay. Clear. Okay. Now see here. P1 will execute first, definitely. So P1 started execution. Exactly after 1 second, you can see over here, exactly after 1 second. So this has executed for 1 second. So we have remaining time of 7. So after 1 second, P1 has executed at least for 1. Who has arrived? The P2 has arrived. So 4 is compared with 7. 4 is minimum, so P2 is given the chance. P1 has not finished. P2 has given the chance. P2 is executing, but just exactly after 1 second, P3 has arrived. So P2 has executed at least for 1 second. P2 has executed at least for 1 second. At least for 1 second, and P3 has arrived. Now what is the time for P3? 9. 9 is compared with the remaining time of these two. Still we found this is smaller. We found this is smaller. So P2 is again given the chance. P2 is so now again executing. Just after 1 second, P4 arrived. So in the meantime, it has executed for 1 more second. That means P2 has executed for 1 more second over here. This is 2 and this is 3. Correct? So when the new process arrived, it is compared with 9, 2 and 7, and still we found this is smaller. So P2 will given chance for another 2 seconds. So P2 will complete up to continue up to 1 to 5. It will continue up to 1 to 5 because it has 4 seconds to execute. So all processes arrived. Now among the 7, 9 and 5, we found 5 is smaller, then we have 7, then we have 9. What is the waiting time for P1? Anybody says what is the waiting time for P1? Anybody says what is the waiting time for P1?
Time.
0 minus 0 plus 10 minus 1. 0 minus 0 plus 10 minus 1. What is the waiting time for P2? P2. What is the waiting time for P2?
0. 1 minus 1.
0.
P2 is 0. I have written some mistakenly of 10 written over here. P2 it is 0. For P3, P3
15.
P3 is how much?
15.
P3 got at 17, 15, arrived at 15. For P4 it is 5 minus 3, it is 2. So this is actually not 10, this is 0. Mistake. This one is actually 0. So 15 plus 9 plus 2 by. So I hope it is understood. Can you solve the problem or not? So this one you take, you will practice at your home. These are the arrival time, lost time is given. Compute the average waiting time, turnaround time, response time in SJF and SRTF. This is a task for you. You do it over at your home. Compute the turnaround time, average waiting time, response time in SRTF. SRTF and SJF both. Is that clear? This is done over here. I've done. So, so what is the limitation of SJF? Knowing the length of the next CPU request is difficult. Although it gives the minimum waiting time, but what is the drawback? Drawback is that how will you know that what is the next CPU burst, right? The long-term scheduling is batch operating system. We can use the SJF provided the user specifies the length. If the user specifies the what is the length of the CPU burst, then we can there is no problem in execution. Although SJF, look over here, this point, although SJF scheduling, look here, although SJF scheduling algorithm is optimal, it is optimal, but it cannot be used for CPU scheduling since it is difficult to know the length of the CPU burst. This line is very, very important, right? So how to know the CPU burst? There is some, there is a prediction formula is given. There is a prediction formula is given over here, but this one, at least you remember that this is generally not being used because knowing the future CPU burst, the CPU burst of the future processes is quite difficult to understand. It will become difficult to know, right? So therefore, what a prediction has been done to predict the CPU burst. Some exponential averaging is being used. Exponential averaging is being used, and that it says that we can have, suppose for example, we will take Tn is the length of the end CPU burst, and Tn plus 1 is the predicted value of the next CPU burst. This is for the current one, and this is for the next one. And we'll take a factor alpha, which will be between 0 to 1. It says that this Tn plus 1 is actually alpha into Tn, the length of the current CPU, and this is the 1 minus alpha into Tn. The formula being generally used for finding the next CPU burst. Anyway, that is not in your, not for your study. This is for your understanding only. Right, not next. This is another problem. No, this is for the, this is the formula just to put the value of alpha and to compute. This is to put the value of alpha and compute. This is the formula I have given. Tn plus 1 is equal to alpha into Tn plus 1 minus alpha into Tn, so that you will compute that what is the CPU burst of the next predicted process. If it is given, the alpha value is given, we can compute it. These are some more examples. There is a question that what will happen if P1 is 0, P2, P3, P4 are 2, at the burst time of P1 is 7, P2, P3, P4 are 5. Can you, Pratik, please explain me? I could not get from your text actually. Hello?
I'm asking if the P1 is
P1 is 0, I understood.
P1 arrival time is 0 and the burst time is
7.
and P1 burst 7. But arrival time and burst time are 5. P2, P3, and P4 arrival time of all the 3 are 2 and burst time of all the 3 are 5. Then which one we will take after P1?
Yes, see. So P after P1, what P2, P3, P4 has same arrival time and same burst time, you are saying?
Yes.
Okay. In that case, I have already told you can use any one of them can be selected. Any one of them, if arrival time and burst time are same, any one of them can be selected. Generally, you will select which is being written first. Right, because even if the tie will not work, because FCFS will not work because all have arrived at the same time, so therefore anyone can be selected. Got it?
Yes, sir.
Okay, so this is one more problem for you. You will do it of your own. This is burst time and this is arrival time. You note down the problem, you will do of your own. Exactly same way. Exactly same way. You have to compute. You have to do it. P1, P2, P3, P4. Their burst time and arrival time is given. You try to solve it. Can you do of your own or not? It is being solved over here. I will share the slide, but you will try to solve of your own. Because there might be some, I have written while writing, so there might be some even, maybe some typo error might be there. So you have to solve it of your own. I don't think this is a typo error, but still you compute of your own. Right? And what is the advantages of SJF and disadvantages of SJF? SJF is basically for long-term scheduling. For SJF, if I am saying, average waiting time of shortest job is less than the first come first serve. For particular set of job, SJF provides the lowest average waiting time. And disadvantages is that the process completion time needs to be known earlier. So we know that what is the burst time earlier, right? Sometimes the problem of starvation occurs. Can you tell me when the starvation will occur? Here it says sometimes. Actually, SJF very rarely the starvation occurs. Can you give example where the starvation occurs? Anyone who can say? Can you give an example where the starvation occurs? For example, there are many short-term processes. Very small processes are there. The long process has to wait for longer time because there are many short processes are coming, right? So that is the main, these are the disadvantages of SJF. So we have completed the SJF and SJF. The next class will go for priority scheduling and round robin other scheduling algorithms. Correct? So let me take the attendance, and in the meantime, if you have any doubt, you can ask me. Roll number 1, 2 is absent. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18. 22, 5, 25, 27, 30, 31, 30, 32, 34, 37, 38, 39, 44, 61,